Okay, so let's read the problem first, and then we'll kind of discuss what type of problem it is. The trough shown in the figure above is 5 feet long, and its vertical cross sections are inverted isosceles triangles with base 2 feet and height 3 feet. Water is being siphoned out of the trough at the rate of 2 cubic feet per minute. At any time t, let h be the depth and b be the volume of water in the trough. So the fact that we're dealing with water in a container and we're given a rate of 2 cubic feet per minute should set off something in your head that says, hey, this is a related rates problem. And I know we all hate related rates problems because they're a pain in the butt, but you know what? We've got to know how to do them. We actually had one on our exam this year on a free response. So we've got to make sure those are set in stone. Okay, so for part A of the problem, it says, find the volume of water in the trough when it is full, which is pretty simple. We're just going to take the volume of this, so we're going to find the area of this triangle, which is the base of it. So that is 1/2 times the base times height, so 2 times 3, times the length of it, which is 5, so times 5, which gives us 15 feet cubed. And always remember your units. AP likes units, and that could lose you points on the exam. Part B reads, what is the rate of change in H at the instant when the trough is 1/4 full by volume? So the first thing we're going to need to do is find what 1/4 the volume is. So we remember that in part A, we got 15 feet cubed as the volume when it's full. So we're going to divide that by 4, or multiply by 1/4, which gives us V equals 15/4 feet cubed. And they left off their units on here, but I added them because you always need to carry your units. Okay, so we know that our volume equation is base times height over 2 times 5. Because the length of the trough never changes, but it's the height that's changing. So we can't just say that the base is 2 and the height is 3 here. But we are not given a rate for the change of the base, nor are we finding a rate for the change of base, so we have to eliminate the base as a variable. So we're going to set up a ratio based on our given lengths from the triangle, which is what this picture right here is. So we're going to solve for that, and we get that b equals 2h over 3. So we're going to substitute that value in for b to this equation to eliminate the b variable. So we get that a new volume equation is that v equals 5/3 h squared. So we know that when v equals 15 over 4, h squared is 9/4, and h equals 3/2 from this ratio over here. So we're going to take the derivative of this function, and we get dv over dt equals 10/3 h times dh dt. Now remember, for a related rate problem, we are taking a derivative with respect to time, so every variable we take a derivative of is going to have a rate associated with it. It's not like a normal derivative where y doesn't have to have it. So, where x doesn't have to have it. So, we're going to plug in our rate that we were given up here for the volume. So, we know that dv dt equals -2, and they left off their units, so we're going to add that in. That's -2 feet cubed per minute. Do not leave off your units. Equals 10/3 times h, which is 3/2 feet. Do not leave off the units there, like they did, dh dt. And when you solve for dh dt, you get dh dt equals -2/5, which is -2/5 feet per minute. So our final answer is that h is changing at -2/5 feet per minute when h equals 3/2 feet. And if it's negative, make sure you keep the negative, because negative means it's losing water. So if it's positive, in this case, that would not be correct, because the water is being siphoned out of the trough, not in, so it needs to be a negative value. Okay, so part C of the problem reads, what is the rate of change in the area of the surface of the water, which is this shaded figure right here. Sorry, I know it's marked up a lot. At the instant when the trough is 1/4 full by volume. So we're back to that v equals 15 over 4 feet cubed, and we want the rate of change in the area, so dA dt. And we also know from part B that when the volume is 15/4 feet cubed, that the height is going to be 3/2 feet. So we know that the area of a rectangle is base times height, and we already have this length right here, 5, so it's going to be A equals 5b. So, because we don't have anything for the rate of change of the base, we're going to plug in this v equals 2/3 h so that we can get it in terms of h. So that gives us a equals 10/3 h. So we're going to take the derivative of that equation of a equals 10/3 h, and we get dA dt equals 10/3 dH dt. And we have dH dt from part B, so we're going to plug that in down here, and we get dA dt equals -4/3. And don't leave off your units like they did, because that's a big no-no for AP. So the final answer is that the area is changing at -4/3 feet squared per minute when V equals 15/4 feet cubed.